the biggest issue of all the exponent rules are negative exponents. If you have x and you raise it to the negative n, what this actually means is that you are taking 1 and dividing it by x raised to the positive n. Or as I try to emphasize to students, if you have a negative exponent on top, it's going to be a positive exponent on the bottom. That also means that if you have x to the negative n on the bottom, you can actually move it to the top and say x to the n on top. And you could think of that as being over 1. What a lot of students will make a mistake on is they see 8 and they raise it to, let's say, a negative 2. A lot of students will tell me the answer could be negative 16, which really is quite, I know where the mistake is made. It's kind of a big mistake because they're not even using powers. Or they may say it's negative 64, which is a more common mistake. That's not correct. All that negative 2 means is that I'm actually going to put that in the denominator, make it 8 squared, and the answer is 1/64. If I had a fraction and I say 3/7 is raised to the negative 3, you have to still follow the rules and realize that 3 is raised to the negative 3. 7 is raised to the negative 3. Well, if I do that, I could try rewriting this first as 1 over 3 cubed, and I could write that as 1 over 7 cubed. To be honest, I wouldn't do that. I'm not saying you're doing anything wrong. I just think it's harder for students to master. I would be more inclined to skip this step and just say, okay, fine. If I had 3 raised to the negative 3 on the numerator, then 3 to the positive 3 will be in the denominator. If I see 7 to the negative 3 in the denominator, I'm immediately going to write 7 to the 3 in the numerator. So if you really look at this, what I'm saying is you could have all along said 3/7 raised to the negative 3 could have been written as 7 over 3 to the positive 3. Again, apologize for the pen. And since 7 is 7 times 7 times 7, that would end up being 343, and 3 cubed is 27. And that leaves you with your final answer. X to the negative n, x to the 1 over n. Very common rules that get mixed up quite often, sometimes with each other, sometimes students just mess them up. For example, 7 to the negative 2. I have heard on numerous occasions that the answer is negative 49 because they think it is 7 squared with a negative in front. That is a no-no. What it is 1 over 7 squared. Take the negative exponent, move it to the denominator, have 7 squared, you get 1 over 49. If I happen to see 7 to the 1/2, it does not mean move to the denominator. What it means is the square root of 7. Again, if I had 125 raised to the negative 3, what this means is I'll move it to the denominator and write 1 over 125 cubed. 125 raised to the 1/3 means the cube root of 125, and the cube root of 125 would be 5. Now what gets very interesting is when you decide to merge both these rules together and, for example, say 125 is raised to the negative 1/3. Well, my suggestion is always deal with the negative exponents first. Therefore, I will first write 1 over 125 raised to the 3rd. Then I will realize that is 1 over the cube root of 125, which means my final answer is actually 1 over 5. 16 over 9, and I raise that to the negative half. Well, you can do this a couple of ways. You could deal with the negative exponent by moving the whole thing to the denominator, which is 16 over 9 raised to the half. Then you could realize that that meant the square root of 16/9, which is the same as 1 over the square root of 16 over the square root of 9, which means 1 over 4/3, which means multiplied by the reciprocal, 1 gets multiplied by 3/4, and I come up with 3/4. What I think I prefer to do in a problem like this is when I have a negative exponent of a fraction, I would switch the numerator and denominator right away. Say this is 9/16. Now raise it to the half, which means now this is 9 to the half over 16 to the half, which is the square root of 9, which is the square root of 16, which is 3/4. The last one that causes students a lot of grief is the difference between x plus y raised to a power and xy raised to a power. We already know, based on the rules, that this is going to be x to the n, y to the n. So if I had just simply done a problem, x, times y raised to the second, I would have gone x to the second, y to the second. I'm actually going to take a moment and pretend that x is 3 and y is 4. This would mean that I was asking you to go 3 times 4 raised to the second. This is 3 squared times 4 squared. This is 9 times 16. This works out to be 144. If I had actually done 3 times 4, this would have equaled to 12 squared. 12 squared equals to 144. On the other hand, this looks so similar to this that students think that this is equal to x squared plus y squared. And that couldn't be farther from the truth. Okay, let's be clear. It's not that far off, but you're missing sort of a big thing. And that is, if I actually had to write out x plus y times x plus y times dot, 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 I would have to do a lot of distributing. So let's just change this n here and make this a second. That would mean this would just be x plus y times x plus y. If I distribute the x to not just this piece, but also to this piece, you're going to find out that that's x squared plus xy. So when I distribute the y to this piece and to this piece, that's going to be yx plus y squared. Well, these two are essentially the same piece. Just because xy is written as yx, that doesn't mean you can't combine them. And your final answer is going to be x squared plus 2xy plus y squared. This is not as simple as just taking each piece and squaring it. So I'm going to demonstrate that again, how you have to make sure that's the case, because I can actually stick in numbers. So let's just assume x was 3 and y equals 4. And I decide to cheat and not actually FOIL it out, or what would be considered distributing, and I just thought it would be x squared plus y squared. Well, x is 3, y is 4. If I square this, I should come up with the same as 7 squared, which is 49. On the other hand, if I follow these rules, I only have 3 squared plus 4 squared. Well, that happens to be 9 plus 16, which is 25, and no, they are not equal to each other. So you would realize there's still one more piece that was never figured out, which is 2xy, which is 2 times 3 times 4, which is 2 times 3, which is 6. 6 times 4 is 24. If I would add it by 25 times plus 24, then you would realize, yes, I actually do have 49, and that is why it's imperative you don't try to shortcut. When you are adding or subtracting, meaning you're having multiple terms, this is a term, this is a term, do not try to shortcut with the exponent rules. They do not apply.